So, before we go on to the examples, one thing I want you to make note of is that what we worked on the other day with addition and subtraction equations is a little bit different from what we're doing today. When we did this lesson, we learned that to solve this equation, x plus 4 equals 7, the opposite was to subtract 4 from both sides. So plus 4 minus 4 canceled out. We did the work, and what we would get is an answer of x, and then the 4's disappeared, x plus 0 equals 3, or in other words, x equals 3. So realize here that the goal here was to make this number disappear by zeroing it out. Okay, now notice how today's goal is a little bit different. Here, we're trying to get rid of this number that's next to n, 3n. If I make 3 into a 0, 0n will just completely disappear, and the n that I was trying to get an answer for vanishes. So realize that what we're trying to do in terms of what we're considering canceling this time is we're still doing opposites. 3 times n, we're going to do its opposite. We're going to divide both sides by 3. These 3's are going to cancel. And then we're going to do the math on this side, which gives me this. 3 divided by 3 becomes a 1 times n, and 1n equals n. And on this side, 12 divided by 3, we get 4. So realize with addition subtraction, we were trying to do opposites to get rid of that number completely. But with multiplication and division, it's a little bit different because we want to change this coefficient number, the number next to our variable, to a 1, not a 0. So there's some slight differences. But the thing you should stay focused on is that what we're really trying to do here is the idea of opposites. Here, plus 4, we did minus 4, and what we did to one side with the property of equality, we did to the other side. There's no difference here. Here it was times by 3. So here we divide by 3. We do its opposite, and what I do to one side, I do it to the other. All right, so let's take a look at some examples. So as you saw in the last couple of slides, when we're trying to solve equations dealing with multiplication or division, the work is slightly different. Now, the goal is still the same. We're still trying to get x by itself to figure out what x is equal to. But the way in which we get rid of, like in this case, multiplying by 3 is a little bit different. In the last lesson, addition subtraction, we were trying to get this to 0 out. But here that's not the case, because if we make 3 into a 0, 0 times x, regardless of what x is, becomes 0 and disappears, and the variable that we were solving for is no longer part of the problem. So instead, what we're actually shooting for is we're trying to get this number to become a 1. That way we get 1x, and 1x is the same thing as just x, and we get our answers. So just realize that even though the idea is we're still trying to get x by itself, the way in which we do it is a little bit different when it comes to multiplication and division. Now in this case though, what we want to do is like what we saw in the balance scales, that here we have 3 x's, which equal 12, but I only need to know what one of the x's is equal to. So what I'm going to do is I'm going to divide up this side by 3 and get myself down to 1x. And once again, I can keep the balance scale balanced because if I divide the left side by 3, as long as I divide the right side by 3, I keep the scale balanced, or the equation balanced. Now here, what goes on is 3 divided by 3, leaving the x untouched. 3 divided by 3 is 1, and the 1 times x, 1 times anything is the number itself, and so 1 just essentially disappears. But once again, notice how it's not becoming a 0, it's becoming a 1. It's a little bit different with multiplication. Now, on the right side, 12 divided by 3, that's easy, that's 4. So x equals 4. And if we go back and check our work, 3 times x equals 12. 3 times 4 is 12, and that works. Now, another discussion. Notice how I showed my work. I divided the left side by 3 to make the multiply by 3 cancel out. What I did to one side, I did to the other, and I showed all my work. Now, a different way to show this work, if I take the same problem, would be like we discussed in the last lesson. I know I'm trying to get rid of the 3, which is a times by 3, so I'll just cross it out. And on the other side, I'll do its opposite, which is to divide by 3, and here I get x, or 1x, equals 4. All right, let's take a look at some more problems. How about this one? M divided by 5 equals 30. Or think of it this way. I've got 1/5 of an m. But I need to know what 1m is, not a fifth of an m. So what we're going to do here is we're just going to do the opposite. Divide by 5, the opposite in math would be to multiply by 5. And if you think about it, 5/5 gives you 1 whole m. Okay, or in other words, 5 divided by 5 becomes 1, and we get 1m. And I can do that because what I do to one side, as long as I do it to the other side, 30 times 5, I get 150. 1m simplifies down to just m, and we get 150. And if I check my answer, 150 divided by 5, does it equal 30? Do the math. Yes, all checks out. Looks good. Okay, so now let's keep going. Now take a look at this problem, another division problem, r divided by -8. So what we're going to do is just the opposite of dividing by -8, which is to multiply this side by the same number. And once again, just want to emphasize this, just for like the last lesson. I'm doing the opposite of the operation. They divided, I'm multiplying. The number is -8, which doesn't change. I didn't change this to +8. Okay, the only thing I'm doing the opposite of is the operation, but the number itself stays the same. So times by -8. What I do to one side of the balance scale, I do it to the other side. Now these will naturally cancel each other out. We get r equals, and this would be -4 times 8 is 32, carry the 3, 2 times 8 is 16, with the 3 is 19, so -192. And if I check it out, -192 divided by -8, negative and a negative make a positive, and 8 divided into 19 is 2, with a remainder of 3. 32 divided by 8 is 4, and so 24 does equal 24. All right. Now, how about this one? This one's a little tricky. This stumps some people sometimes. -n equals 14. So how do we figure this one out? Well, I think what's the confusing part for a lot of people is that there's no number here, but there's a negative. But remember that just like in these examples, where 1m is the same thing as m, that next to a variable there's always that invisible 1. We usually just don't bother writing it. But in this case I think it'll help. If I put the 1 back in here, what I've really got here is -1 times n. So what's the opposite move of timesing by -1? Well, it's to divide by -1. And what I do to one side of the balance scale to keep things balanced, I need to do it to the other side of the equal sign. Okay, -1 divided by -1 cancels out and becomes +1, n. And 14 divided by -1 is -14. Over here, 1 times n, the 1 just disappears and n stays. So n equals -14. And if I check it out with the original problem, this is what it would have looked like. -n, in this case n is -14. So notice, this is the negative from the original problem. This negative is from the answer. Equals 14. Negative times a negative makes a positive, and they cancel each other out, so 14 does equal 14. All right, let's take a look at one last tricky one. Fractions. Now, it's not really tricky. We know the steps, but I'm going to show you a little shortcut that you can think about. Here, we're timesing by 2/3. So naturally, you would think that the opposite here would be to divide by 2/3 and divide by 2/3, which is the case. On this side, we just know that these are going to cancel because we've done opposite operations. And then over here, what we get is 10 divided by 2/3. But if you think back to your work on fractions, that when we do division with fractions, there's actually an easier way. You can actually divide with fractions, but it gets pretty complicated in certain situations. So somebody figured out that what you could do is, rather than do division, you could take 10 and multiply it by the reciprocal of 2/3, which is 3/2. Okay, this is something we should have learned in a previous class, and it's just we're doing a little refresher on it. So eventually what we get is g equals 10 over 1 times 3 over 2. So the numerators, 10 times 3, that's 30. The denominators, 1 times 2, that's 2. And of course, 30 divided by 2 is 15. This one we should definitely check. 2/3 times 15 equals 10. So the way we do this is make 15 into a fraction, 15 over 1. 2 times 15 in the numerators would be 30. 3 times 1 in the denominator would be 3. And 30 divided by 3 is 10. 10 equals 10. All right? And so what I'm basically trying to get at here is that if you think about it, this one situation where we have to divide by a fraction, we always do it the same way when it comes to actually doing the math, is that we always switch it from dividing by the fraction to multiplying by the reciprocal. So if we take this as a known fact that, you know what, in these problems, why don't we just skip straight to that problem? So what I'm suggesting is, let's say I gave you that same problem, that anytime you get a problem like this where they're multiplying by a fraction, and we know the move is to divide by a fraction, rather than going through all these extra steps where we actually know eventually we're going to change dividing by a fraction into multiplying by its reciprocal, why not just jump straight to that step? So here's that same problem, but done again. So here they're multiplying by a fraction. So I know that eventually this is going to turn into multiplying by the reciprocal. This is just kind of a special situation that if you can remember this scenario, it'll save you some of these steps up here. So what I do to one side, I'm going to do it to the other. And I can show you why this still works here, because take a look at what happens. Across the top, 3 times 2 is 6. Across the bottom, 2 times 3 is 6. And the g. 6 divided by 6 is 1. And like we've been talking about, 1 times g is just g. And so even by using this little reciprocal shortcut, we're still going to get the same result. This is all going to cancel out and just become g. Now over here, 10 over 1. And since it's already multiplication, we can just dig right in. 10 times 3 is 30. 1 times 2 is 2. 30 divided by 2 is 15. All right, so that's just one special case to kind of keep in the back of your mind. It'll save you some work. Now, of course, there's nothing wrong with doing it this way of going through all your steps, but you're going to be doing a lot of repetitive work knowing that this is always going to happen. Okay, so just something to think about as you tackle problems with fractions.